Okay, so you guys remember we did our geometry lesson a couple weeks ago. We did our first part of geometry. This is the second part of the geometry concepts that we do on the MCAS. So some of the things we'll look at will be the coordinate plane, translations, rotations, and reflections, and just slope formula. Slope formula and slope-intercept form. You guys remember y equals mx plus b, right? Yeah, good. Okay, so let's turn to the second page here. And these first few questions are going to be mostly reviewed for you guys, but it's good to look at anyways. Okay, so some test questions on the MCAS will be about coordinate planes. Coordinate plane is a graph with 4 quadrants, 1, 2, 3, and 4. Has an x-axis that goes horizontally and a y-axis that goes vertically. So what you guys need to know is you guys probably get a question like where it'll show you a point, and you guys will have to determine what quadrant the point is in. Sometimes I get a little bit confused. Sometimes I think the top left quadrant is quadrant 1. But a good way to remember that is that the first quadrant is the x is positive and the y is positive in quadrant 1, right? No other quadrant is like that. And then they go counterclockwise from there. So 1, 2, 3, 4. You guys see that? Okay. Sometimes you might have a tendency to think that the top left is quadrant 1, but indeed it's the top right, where the x and y are positive. Okay. To find coordinates on a coordinate grid, you guys know how to do this. You move along the x-axis first, and then you find your vertical axis, the y. You find where the point is. So, and you guys all know that for every point, x comes first, then y, right? Okay. All right, let's flip over and do these first. These first 4 questions, I think, are going to be pretty much review for you guys. So if you guys want to do them together real quick, we can just go through them. Give the coordinates of point P on the graph below. Emily, what are the coordinates of that first point there?
-2.
Yep. Was that Esteban? You guys can start. Do you need a pencil? You got one? Do you need a pencil for me? Just follow along and circle these answers. Okay, number 2. Esteban. What are the coordinates of point D?
-4.
Yep. Get a little extra question of what quadrant is point D?
3.
Yep. 1, 2, 3. Yep. Perfect. Courtney, which point on the graph below has the coordinates -4, -2?
Point B.
Yep. Everyone get that? And then this last one's a little bit tougher. Nikki, we're saving it for you. The 3 vertices of a quadrilateral are 1, 3, point A, 5, 3, point B, and 4, -2, point C. When used as the last vertex, which point would make the quadrilateral a parallelogram? You guys can graph all 3 of those points if you want to figure out, or all 4 of them to figure out which one would make it a parallelogram. You guys remember what a parallelogram is? Not necessarily right angles, but all sides are parallel. Okay. You guys figured out? What would you get, Nikki, for a point? Which point?
Either C or B.
I think, what do you think, Emily? Which one would make it a parallelogram?
B.
Yep, B, right? 0, -2. Because both those sides are at an angle, right? Here's mine, right here. Nikki. I thought the same thing. You can see I made the point there too, right? You see that these aren't exactly lined up there. So the 0, -2 would make all sides parallel. See that? Esteban, you good with that one? Okay. All right, let's move on to transformations. So we're going to have 3 types of transformations we're going to go over. We're going to talk about rotations, reflections, and translations. Okay? Some of you probably saw, you remember seeing this in geometry. Courtney, Nikki, you probably saw this in geometry. Emily, you'll see this in a couple of weeks coming up, so you're getting a little bit ahead of the game here. Okay, transformations. Some test questions will be about transformations, the movement of figures on a coordinate plane. On the MCAS, you might be asked to choose the correct coordinates of a figure moved in a certain way on the coordinate plane, or you might be asked to move a figure on a coordinate grid. The following are some common transformations. So, Esteban, you want to read us that first one?
Rotation.
Yep.
When you rotate a figure, you move it around a fixed point, which is called the center of rotation. The rotation can be large or small. The rotation of 180 degrees is called a half turn. The rotation of 90 degrees is called a quarter turn.
Yep, so half turn, quarter turn. The thing to remember about that is it's a rotation around a fixed point. So you see, here's the fixed point in both of these rotations. It rotates around it. Okay? Okay, Courtney, you want to read to us about, tell us what reflections are?
When a figure is reflected, it is flipped across a line that may or may not be visible. The reflection of a figure is a mirror image.
Yeah, so it flips it over. So you guys see it changes the orientation of the, in both the rotation and the reflection, changes the orientation of the shape where it's not going to look exactly the same, right? A lot of times with reflections, you guys will see questions like reflect the shape about the x-axis, which means flip it over the x-axis. Or you might even say, see a question that says flip it across the line x equals -2, and that would be that vertical line, right? X equals -2, and you can flip it over that. We'll do an example together here in a second where you guys have to reflect it over the x-axis. Okay, Nikki, can you tell us what translations are?
Well, the translation is a slide. A figure that is translated is moved as if you were sliding in one direction.
Yep, awesome. So you see, with that one, the orientation doesn't change. You're just moving it from one place to another. Okay, let's do this open response question together on transformations. Here, Esteban, let's use. They give you that tiny little graph there. Let's use a piece of graph paper for it. I think it will be much better. So you guys want to draw a coordinate plane first, and then plot these 3 points of the triangle: A, 3, 4, B, 5, 8, and C, 7, 4. Let's just make a coordinate plane real quick. The one they give you there is just